I think we'll go ahead and get started. Thank you all for being here. I'm Nat Weston, chair of the Earth Day Committee, and really a lot of the heavy lifting is done by others on the committee, including Liesl Schwartz, who is here tonight, Michelle Moss with Dining Services. So hopefully some of you got out and enjoyed our farmers market and sustainability fair today. We're very lucky we managed to wrap that up right before the rain hit. It was actually a pretty close call. So it turned into a very nice event, so I hope you were able to take advantage of that. So thanks for being here tonight. Just wanted to plug a couple of the other things that are still coming up. One is a panel discussion tomorrow morning at 10 on sustainable solutions, sort of in some ways a counterpoint to this evening's talk. We have 5 panelists coming in from a variety of careers spanning from business to engineering to working in nonprofits to talk about their careers in working towards sustainability. And Liesl will actually be moderating that. So that will be in the Falvey Library Speakers Corner, if you can join us for that tomorrow at 10 a.m. And then there's a climate march organized by the CRS Ambassadors Program tomorrow afternoon. And then a day of service on Saturday, student organized Earth Day of Service. If you can join up with that if you haven't already. The website, I think you've probably all received emails from us. If you haven't, it's on the posters that are out in the lobby. You can find the website and sign up for that. We would love to have you. So that'll be Saturday morning, then followed by a celebration in conjunction with Spring Out. There'll be a barbecue and lots of other fun things happening on Saturday. So hope you can join us for that. And tonight, what we are doing is here we're doing a keynote presentation on the politicization of climate change science. So we have Mark Doherty here from the ethics program who will be moderating this discussion. Just before we get started, I just wanted to thank the many folks who have supported us in this effort. So the Office of the President, the College of Liberal Arts and Sciences from the Dean's Office, the President's Environmental Sustainability Committee, which is largely Liesl. Again, she does a lot of the heavy lifting. Falvey Library, Dining Services, especially with the farmers market today. The Ethics Program, Villanova Center for Liberal Education, the Villanova Center for Energy and Environmental Education, the Villanova Center for Global Leadership, the Villanova Center for the Advancement of Sustainability and Engineering, a lot of Villanova centers there. The Center for Peace and Justice Education, Maintenance and Grounds, certainly they help also out a lot with the sustainability fair. And then the Departments of Geography and the Environment, which is where I am, Civil and Environmental Engineering, and the Department of History. So thank you all for the support you've given us. And with that, I will pass this over to Mark to moderate our discussion tonight.
Good evening, everyone. It's a privilege for me to facilitate this evening's conversation, although I've got the easiest job, which is simply to welcome you and introduce our speakers. We have an impressive panel for you this evening, and I will introduce them. But before I do that, I'd like to talk about why I put forward this idea to have a keynote that focuses on the politicization of science. There's an impressive body of scientific evidence accumulated over at least the last 50 years, if not 100 years or so, that makes clear one thing. Human behavior has had a serious impact on the global climate, far outpacing the impact that other non-human factors have had. While the conclusions of any particular scientist are not 100% certain, the conclusions of multiple scientists converging on the same conclusion suggests that the probability of their accuracy rises to a level at which rejection of their conclusions borders on the irrational. However, there are elements in our society, both here in the US and abroad, that do reject the findings of science, and some do it on putatively scientific grounds. That rejection, magnified through the echo chamber of talk radio and TV, has led us to a public policy and cultural practice impasse that can very well lead us to not act in the face of what the best science available identifies as a globally defining challenge. Somehow, In all of this, the at times mythical neutrality of science has been challenged, undermined, called into question, and rejected. Do we really want to argue with scientists about the structure of the solar system? Do we argue with them about the makeup of the stars? Does anyone really challenge that 2 + 2 = 4? I brought the idea of this panel to the Earth Day Committee because I think it's a moral imperative for us to understand what science is and what it is not, to understand how vulnerable science is to distortions that are not part and parcel of the scientific enterprise, and to understand how critical it is for us, citizens, to engage science on topics like climate change in order to be informed and so make better decisions when it comes to personal behavior and public policy. If we don't do that, I imagine us being like the farmer who comes up out of his tornado shelter after the tornado, looks around at the destruction around him and says, "Wow, Ma, can you believe this happened?" So I'm looking forward to this conversation because I'm actually kind of stunned at the fact that we are in our country, at least in the United States, where we are with this discussion. So I'm looking for some enlightenment, panelists, on why that's the case and how we can move forward. So I'd like to introduce each panelist first, and then they will each address you. So our first is Dr. Benjamin Horton. He is a professor in the Department of Marine and Coastal Science at Rutgers University. His research concerns sea level change. He aims to understand and integrate the external and internal mechanisms that have determined sea level changes in the past and which will shape such changes in the future. He has published over 140 articles in peer-reviewed journals, including Science, Nature, the Proceedings of the National Academy of Sciences, and Geology. He is supervising or has supervised 20 students to the degree of PhD and 9 postdoctoral students, of which 11 now occupy academic positions. He is a fellow of the Geological Society of America and the recipient of the American Geophysical Union's 2014 Voyager Award. He is an author of the Intergovernmental Panel on Climate Change 5th Assessment Report. He's a committee member of PALC, and a project leader of the International Geoscience Program 588. So quite impressive person to come to talk to us about, because talk about a politicized document. The IPCC document certainly has been. Secondly, we have, they're not sitting in the order because I didn't do that right. That's my fault. So next we'll hear from Susan Stein from the Department of Communication, Drexel University. She is an associate teaching professor in that department and director of the MS Com program in the Department of Communication at Drexel. Her work sits at the intersection of science and communication, with particular interest in media effects and communication about health and environmental issues. Her PhD is in mass communication with an emphasis in energy analysis and policy from the University of Wisconsin-Madison. She holds an MS in natural resource management from the University of Wisconsin. Secondly, we'll hear from Greg Vitale. He's a member of the House of Representatives in the state of Pennsylvania, serves the citizens of the 166th Legislative District, of whom some are here. So be on your, mind your P's and Q's there, Representative. He is the Democratic chairman of the House Environmental Resources and Energy Committee, and his focus in the legislature has been on climate and energy issues and government reform. Representative Vitale has received several awards recognizing his leadership in environmental issues. And finally, we have Carol Hager. She is a member of the Political Science Department at Bryn Mawr College. She is interested in grassroots citizen participation and with different forms of community involvement in land use planning and energy policy making in the US, the UK, and Germany. Her current work focuses on the role of citizen activism in Germany's transition to renewable energy. Dr. Hager co-founded the Bryn Mawr College's New Media Project and serves as the director of the Center for Social Sciences. So I've asked each of them to come up and offer us some remarks, and then at the end, we'll save questions until the very end, and then we'll open it for a conversation, okay? So I'm sure you will enjoy what you're going to hear. So, Dr. Horton.
Okay, good evening, everyone. I thank you for attending. I feel a little bit nervous giving this talk because I don't think I have given a talk in front of any members of my family before, and sat in the middle is my 14-year-old daughter, and so I better impress her, or she'll tell her mum. So I'm going to talk to you today in the next 15 or so minutes about climate change indicators. And they are an alternative media to try and display the information regarding climate change. They can be any physical or social sciences discussed over any spatial scale or any temporal framework. Why we must do this is because the common mechanisms for which an academic tries to influence policy or educate the public has quite simply failed in this nation and beyond. So it doesn't matter whether the National Academies in their recent report states that changes observed over the last several decades are due to human activity. It doesn't matter whether the largest scientific organisation on our planet, the AAAS, says that global warming is not a theory, it is a fact. They talk about the scientific predictions in the recent report, saying that the processes are atmospheric gas concentrations and deforestation, and that these predictions now match our observed changes. We can go internationally to the IPCC. 5,000 scientists agree on a single topic. Now, you as undergraduates, you know that 5 departmental academics can't agree on anything. So just think about how powerful that information must be for the IPCC to state that warming of our climate is unequivocal, and that there is a very high confidence, that means a 95% certainty, that the effect of human activities has been one of warming since 1750. So despite this, the general public does not agree, and despite this, we have an inaction from our policymakers. And if we move outside the academic realm, we can look into the private sector. This graphic shows the incidences of events published by Munich Re in 2011. So it runs from 1980 through to 2011, and these are the number of insurable events, and we can see that we have a strong increasing trend. The shades in the green are the tropical cyclones, such as Hurricane Irene or Hurricane Sandy. In their report, they stated that the climate changes are already evident in the last few decades in North America. And when they compare North America with other continents on our planet, they state that the risks are changing faster here than anywhere else. So what are the causes for this? Well, they are our greenhouse gases. We know the elemental relationship to heat since the latter part of the 19th century. Greenhouse gases such as carbon dioxide, methane and water vapour. They act as a blanket around our Earth, increasing our temperatures. So despite projections made in 1990 about the dire consequences of increasing our amount of greenhouse gases, they just keep on increasing. So this is the emissions of carbon dioxide from when the first projections were made in 1990 through to 2010. A clear increasing trend of carbon dioxide with the vast amount from the energy sector. Now, we're also very fortunate in our community that some of the greatest minds go to the most extreme environments to provide information, provide a context for our greenhouse gas emissions. So this graphic here shows the changes in temperature and the changes in CO2 over the last 700,000 years. These come from annual layered ice in Antarctica. So the top graphic shows that the Earth's climate has waxed and waned between glacial and interglacial episodes over the last 700,000 years. On the bottom graphic, the information comes from air bubbles within the layered ice. We see that CO2 has moved, increased between around 180 parts per million by volume to 280 parts per million by volume. And the thing that is striking about this graphic that you can all see is that whenever CO2 goes up, the temperature goes up. Whenever CO2 goes down, the temperature goes down. Now, I amended this figure, and I wanted to plot on what our current day, present day level of carbon dioxide is. Last year, for the first time in 40 million years, carbon dioxide rose to 400 parts per million by volume. 120 parts per million by volume than seen upon this graphic. So what have been those effects already? Well, temperatures of our planet have increased. This graphic here shows the temperatures from 1900 to 2013. It's around a 0.8 of a degree C rise, or around 2 degrees Fahrenheit, recorded in all continents, recorded in urban and non-urban areas. But the mass amount of heat on our planet has been absorbed by our oceans. These are the changes in sea surface temperature, that's the upper 700 metres of water, from 1901 to 2012. We see that there is spatial variability, but certain parts of our ocean are having increases in temperature in excess of 4 degrees Fahrenheit. Now, there are many impacts of this change, but I study sea level change. The big impact of this in my sphere is that when you warm up ocean water, it occupies a greater space. This thermal expansion is responsible for around 50% of the sea level rise we've seen in the 20th century. Now, there are other indicators, glaciers. So glaciers normally have a balance. The melting in the summer is balanced by the precipitation in the winter. But with climate change, we have a mass balance problem. We have enhanced melting in the summer and decreased precipitation in the winter. And therefore, you get these iconic photographs. This is the Muir Glacier in Alaska in 1941. This is what the glacier looked like in 2004. We can graphically show this. This is the mass of our glaciers from 1960 to 2010. Since 1960, glaciers have lost more than 2,000 cubic miles of water. This water ends up in our ocean basins. It's contributed about a third of our sea level rise of the 20th century. But as we move into the 21st century, as this image shows, there's really not much of this ice left. It will only contribute a few inches to sea level rise in the 21st century. But we have two large ice sheets, Greenland and Antarctica. And Greenland suffers from enhanced melting in the summer. This graphic on the right-hand side shows the increase in the number of days that are melting. So in 2012, in the areas in red, had 30 extra days of melting compared to the long-term average. Greenland also suffers from a decreased precipitation, so we have a mass balance problem. This graphic shows how many tons of ice are being deposited into our oceans. And this ice sheet is big. It covers 500,000 square kilometres. It has enough water within it to cause sea level to rise over 20 feet. But Antarctica is even bigger. Antarctica covers over 5 million square miles. It has enough water within it to raise global sea levels by over 200 feet. And it also suffers from a mass balance problem, and it has additional issues as well. So on these satellite photos of an ice shelf, you can see these dark areas. And these are surface pools of meltwater. And through the process of gravity, these meltwater pools migrate to the base of the glacier or the ice shelf, lubricating it, causing it to move at a faster velocity, causing it to collapse. Now, regarding our ice shelves, In the 1970s and 80s, we thought the time scale for a collapse of an ice shelf may be 1,000 years, maybe 100 years, maybe a decade. Not a year, but we found out in 2000, in the 21st century, that in quite simply in 5 weeks between January and March, an ice shelf the size of Rhode Island collapsed. It had been stable for 12,000 years. Now, the information we have regarding sea level is very, very worrying. In the 20th century, our ice sheets contributed around 25% to the sea level rise. But in the 21st century, they're increasing to 40%. What about sea level rise? So if you put together the expanding oceans, the melting glaciers, and the melting ice sheets, you can know what the processes are that control sea level. So this is a graphic from a paper that we have coming out next month. So we compiled together all the instrumental records of sea level. So instrumental records come from tide gauges located in the ports around our world that record high and low water for our mariners, the average of which is sea level. So from 1880 to 2010, sea level is quite clearly rising year upon year. The bottom graphic is more worrying, though, that the rate of sea level rise is accelerating from around 1 millimetre per year in 1880 to present day rates of 3 millimetres per year. And this rate is increasing year upon year. The next question to ask is, are these rates unusual? And we're able to also look back through time. And this is really what is my bread and butter, is to look at past sea level changes. So this graphic here shows the changes in sea level over the last 10,000 years. So this is an Earth's period known as the Holocene. It's when the Earth's climate warms up from the last glaciation. Temperatures warm up, our oceans expand, and our ice sheets melt. And it caused sea level in New Jersey to rise by around 25 metres or 75 feet. On the right-hand side shows that the rates have changed because they're going to temporally vary. So we have the average rate of change in the solid line and the error associated with it. In the early part of this record, from 10,000 to 6,000, the rates of sea level change were quite similar to what we are experiencing today. But in the last 4,000 years, they stabilise. Sea level stabilises to a relatively low rate of around 2 millimetres per year. Again, I recently amended it. I put on what the present day rate of sea level is from the Atlantic City tide gauge. It's around 4 millimetres per year. This rate of sea level rise has not been seen for 67 centuries. Now, this is rather an abstract graph. The next question to ask is, how did it affect our coastlines? And again, fortunately, we're able to do this. We have a display at the Franklin Institute in Philadelphia where we have a series of interactive maps to show you what the coastlines were over this last 10,000 years. So, to orientate you, here's the present-day coastline in black. Here's Chesapeake Bay, moving through to Delaware, New Jersey, Long Island Sound, moving through into Cape Cod. The coastline, when sea level was 75 feet below present, was hundreds of kilometres offshore at the boundary between the green and the turquoise. The increasing depths below sea level are the shades in blue, and the greens to yellows to oranges are elevations above sea level. So 10,000 years ago, the sea level is offshore. So what happens with these fast rates of rise? Well, you inundate, you erode, you lose our coastal landforms. You create an island offshore of Cape Cod. What happens to that island? It is submerged and it is lost. Every single year, tens of metres of coastline are lost with fast rates of sea level that are comparable to today. But then when you reach around 5,000 years, our coastline looks much like it does today because sea level has stabilised. When you stabilise sea level, you allow barrier islands to form, the barrier islands that we live and work upon. The barrier islands allow marshes to form, which are the breeding grounds for fish and other wildlife. Indeed, in a paper that I wrote, I said that there was a strong link between the stabilisation of sea level, the formation of barrier islands, and the birth of our civilization. And as you move through over the last 5,000 years, you can see that the coastline did not change very much. Come on. So we can put all this together and look at a graphic that shows the rising sea levels of a time period known as the Common Era. This is the last 2,000 years. Okay? So you start at 0 AD, moving through to when we produce this graphic in 2013. So these are our geological reconstructions from sediment cores that we retrieve from marshes in New Jersey, North Carolina, etc., showing sea level being remarkably stable, slight increase associated with a climate period known as the medieval warm period, and then it accelerates as you start to dovetail our geological measurements with the instrumental tide gauges. And on the right-hand side, we show the projections into the future, which vary depending on which mitigation scenario we choose to implement in the next few decades, between a low estimate of 25 centimetres to a high estimate of around 1.5 metres. Now, this is a rather provocative graph. It clearly illustrates that the changes in the 20th century are faster than the last 2,000 years. And it's such a strong statement and was easily the most proud moment in my academic career when President Obama used it in his State of the Union address in January 2015. This is a screenshot of the webcast coming out of the White House, and President Obama used our statements in our paper that our sea levels are rising faster than they have in the last 2,000 years. So science can influence policy and can influence the very, very top. But the other thing that we try to do is that we try to take this information to the public, and this is why I gladly accepted the opportunity to talk to you guys today. So this is an example of trying to find different media. So I was involved in a film produced by Ben Kalina called Shored Up, where we tried to take the message of sea level change out to the general public, because in the 20th century, we've already seen the devastating impacts of sea level rise. It causes destructive erosion. It contaminates our aquifers and our agricultural soils. We are losing valuable habitats. This film has been shown 300 times in various areas. It has been banned in certain areas because of its provocative message regarding sea level change. We estimated, Ben and I, that we have shown this to over 300,000 people in the last 2 years. It's been shown at a variety of film festivals. I got to go to film festivals. Now, how cool is that? But whenever I went, after the film was shown, I stood up and I gave a talk, because it's a means to take the information to a different people. So it's coming back to New Jersey, where the program is basically based. We're showing it tomorrow back in my department, and then it's got its next showing is in Pennington on the 26th. Now, the importance of this film is it was released about the time of Hurricane Sandy. And what I want to sort of leave you with is the influence that sea level rise had on Hurricane Sandy. So Hurricane Sandy was a very unusual event. It had an unusual track. It unfortunately occurred at high tide. But the other aspect is it occurred on a rising baseline, and that baseline is sea level. So on this graphic that goes from the 2012 when Hurricane Sandy made landfall, going back to the 1800s, this is the tide gauge, and in the blue is our geological reconstructions. And then we put the timing of landfalling hurricanes in New York City. So Irene and Sandy, Donna in 1960, historical hurricanes in 1893, and this hurricane in 1821. A very interesting hurricane. The storm surge is virtually identical to Hurricane Sandy, but sea level is very, very different. Sea level from 1821 to 2012 was 50 centimetres higher. And that's a result of climate change. So Hurricane Sandy does illustrate the impact of climate change. $68 billion of damage. Lives were lost. We estimated that sea level rise in the 20th century caused 100,000 people in New Jersey and New York City to be flooded that would not have occurred if sea level had not been rising. So if we move through into the 21st century, we are very unsure as a scientific community what the tracks of the hurricanes will be, how strong they will be, or how frequent they will occur. But flooding from hurricanes will be more frequent because sea level is rising. We wrote a benchmark paper last year that stated that Hurricane Sandy, currently thought of as a 1 in 100 year event, if we do nothing to mitigate against climate change, by 2050, it is estimated it will occur every single decade. Now, as a society, can we afford that? No, we can't, because we live along the coastline. 29% of the US population lives along the Atlantic, Gulf, or Pacific coast, or the Great Lakes. We work along the coastline, 45% of our GDP, $6.6 trillion annually. And the relationship between sea level and climate is so very, very clear. So I put together this very simple graphic which shows the relationship between the average temperature of our planet and what average sea level would be, going back through time to periods where the Earth was colder and periods where the Earth was warmer. And I want to leave you with an anecdote. So, from the last glacial maximum 20,000 years ago to today, global temperatures rose by around 5 degrees C. That melted 2/3 of the ice on our planet. Sea levels rose by 120 metres, over 350 feet. If we do not mitigate against climate, by 2100, we will have a further 5 degrees C rise. We have 70 metres or 210 feet of ice on our planet. How much do you think will melt, and how much do you think we can afford? Thank you.
So I did think I was third. If you look at the screen.
Sorry.
Do you want?
Then why don't you, we'll let Greg go.
All right.
Sorry. Oh, you're up, Greg. Sure. Okay.
Wow, what an amazing presentation. You know you're out of your league on a panel when the person before you gives a presentation like that, and your main concern is pronouncing the word politicalization correctly. So, but I will do my best. I'm going to take a bit of a different approach. It's going to be very Pennsylvania focused. It's going to be more science than more politics than science. I actually taught adjunct faculty here many years ago, and an old Villanova Law School professor, Professor Speen, I said, how do you teach a class? And she said, Greg, just tell them what you know. So I'm going to try to do that tonight. I've been in the legislature for 23 years. Let me start my clock. I'm going to give a very relaxed presentation for about 9.5 minutes, and I'm going to rush through the last half minute with everything that's left here. The political landscape in Harrisburg, it's a tough place. I mean, trying to advance climate policy in a coal state is not for the faint of heart. It's a tough place to do business. It's very dependent on how many votes you have. Happily, we now have Tom Wolf as a governor who is going to be much more proactive on climate change issues than his predecessor, Governor Corbett, was. We have a very Republican legislature, both House and Senate. But the interesting thing about climate change and environmentalism generally is it doesn't cut Democrat, Republican per se. In other words, you look at suburban Republicans, their constituencies are better educated and are much, and their basic needs have been met. So they're much more sympathetic to climate change issues than, let's say, the Southwestern Democrats, who are very closely aligned with the extraction industry. So it doesn't really, I mean, when I've tried to advance environmental legislation, I actually was cut off at the knees by my own Democratic Party. So it doesn't necessarily cut Democrat, Republican along that issue, but as a general rule, the Democratic Party, I think, is much more sympathetic towards this issue. But it is a tough place to advance environmental policy generally and climate change policy specifically. The reason why it's so important to do this work in Pennsylvania is that Pennsylvania produces almost 1% of the world's greenhouse gases. The entire world's greenhouse gases, almost 1%. come from Pennsylvania. And they come from two main categories. One is the transportation sector with about 12.7 million people. There are a lot of cars burning gas and trucks burning diesel oil. And in the utility sector, I mean, we just have huge amounts. The electricity that lights this room comes from power plants, by and large, fueled by the burning of coal, the burning of natural gas, and then nuclear, which is carbon free, with a very small fraction coming from renewables. So it's really a very important culprit in the climate change issue. Having said that, what should Pennsylvania be doing? I mean, I think that we need, in the most simplest terms, we need to shift to renewables, and we need to reduce the demand for energy generally. Shifting to renewables, wind, solar, geothermal, and so forth. I think probably the most important thing you can do legislatively is increase something called the Alternative Energy Portfolio Standard, which is the percentage of electricity that companies like PECO need to get from renewable sources. We used to be a leader in that. Maybe 10 years ago, we've slipped way behind. I think you also need to do things like fund what's known as the Pennsylvania Solar Sunshine Program, which gives rebates to put solar panels on your roofs to increase solar generated electricity in the state. But I think also you have to work on the demand side. You have to really reduce consumer demand for electricity generally. And I think you do that. There is one important piece of legislation we passed in 2008 as part of Governor Rendell's energy independence strategy. It was called Act 129, but it required electric distribution companies like PECO, like PP&L, and others to really look for ways to reduce overall demand for electricity. You may have purchased an appliance and you got a rebate from PECO. That was part of their effort to sort of get down to those legislatively mandated demands. I've introduced a bill that would do that. It would also expand that demand reduction strategy to the natural gas industry. Right now, it just applies to electricity. I think another thing that's very important to do is reduce our methane emissions. I think we're all familiar with CO2 as a greenhouse gas, but methane, unburnt methane, is also very potent, many times more potent than CO2, but it has a shorter shelf life, but it's much more potent when it's out there. And I think one of the problems with natural gas, that is in fact largely methane. So when you drill for natural gas, and as it comes out of the wellhead right until it goes to the burner tip in your home, there are opportunities for that to leak through various flanges and other places methane can get out. That's a very powerful greenhouse gas. And I think the way you need to do that, and the good thing for the Wolf administration, given the problems with the legislature, is this is something that can be done administratively. And what you'll probably see is once his Department of Environmental Secretary John Quigley be confirmed, you'll probably see tougher methane regulations moving through the legislature. I think another thing that we as a legislature or we as a state government are charged with doing, which could have a significant impact on our CO2 reductions, is the implementation of Barack Obama's Green Power Plan. That is an EPA regulation that was, it's still in the proposal stage, should be finalized at some point this summer, but that has a goal of reducing, and it deals with existing power plants and reducing CO2 from existing power plants. And that has a goal of about a 30% reduction from 2005 levels by 2030. A very ambitious goal, and it sort of ties into our UN treaty commitments that we've just made with China and submitted to the United Nations. So although that is a federal regulation, each state is given a CO2 reduction requirement, and they need to figure out how to get that. Their various departments of environmental protection need to come up with a strategy to reach those target reduction goals. But there has even been legislation introduced in the legislature and actually passed last term that would politicize that process. It's a constant battle. You would think, if the legislature would just hear a presentation like Professor Horton's, they would just be immediately convinced to act. But why aren't they? I mean, regrettably, I think it's just the way the legislature acts when and what it's driven by. And when I tried to move in the past legislation relating to renewable energy, got enormous resistance from basically three sources: the coal producers, the utilities, and the Chamber of Commerce and the Chamber of Commerce. They really fought this tooth and nail. I mean, there's an interesting, and you can explain the way Professor Horton did explain, but I came upon this quote by Upton Sinclair a couple of years ago that I liked that sort of illustrates the point, and his quote was, "It's difficult to get a man to understand something when his salary depends on his not understanding it." And I think that's really true with regard to legislators, and it's true with the people you deal with in this industry. I mean, I think most of us act in our own self-economic interest. If unions, if there's a pipeline job, they view that through the lens of jobs. They don't view that from the lens of creating long-term structural things that are going to prolong fossil fuel use. If the coal producers, when they see renewable energy legislation proposed, they think more solar, more wind means less coal, less jobs for us. I think that's the reality of what happens in the legislature. I think I think that legislators they try to do the right thing given the parameters of holding on to their own job. They generally won't go beyond that. And I'm just going to throw kind of crazy off-the-wall thought to you that kind of help me understand this a little bit. When I was maybe a freshman or sophomore at Villanova, I was in a very sort of, took my literature and my history classes and walked the, passageways with the professors thinking all grandiose thoughts. And then I got a job in the summer for $2 an hour painting in the summer heat, Sheehan and Sullivan and all these dorm rooms. And I almost looked at my former self in the spring with sort of like contempt. It's like you just don't care. If you are out painting rooms in the heat, those grandiose thoughts mean very little to you. You just want to get through the day. And I think that's how sometimes I understand why people view these issues differently than I do. And that's a reality I think we have to deal with. Climate change is a Climate change is a particularly difficult political issue because by the nature of it, the cost of dealing with it is paid for before the next election, and the benefits of it come after the next election. Politicians like it just the opposite way. It's a tough issue. It never shows up on anyone's top 5 issue lists. I've noticed the issue sort of, and it doesn't have an immediacy to it. I've noticed it slowly was creeping towards the center mainstream, and then the economy fell, and then people stopped thinking about it. And then Hurricane Sandy came, and people thought about it for a while, and then there was some mass shooting in a school, and people stopped thinking about it. It's one of those issues that it lacks, I think, the immediacy of other issues. Let me just sort of skip through. I mean, so what can citizens do? I do think elections matter. I think citizens have a responsibility to pay attention. They have a responsibility to pay attention to who's doing what on the issue. And I think at some point, just stepping forward. We just elected a 27-year-old woman to the legislature from Philadelphia. So, it's stepping forward. It's stepping forward. I mean, someone has to do it. What do they say? The penalty of not running for office, it's being governed by your inferiors. I think just it's important to just step forward. With that point, the only final thought on this, although it just seems like a very difficult issue, and those of us who just kind of keep plugging, sometimes it's discouraging, but I sort of look at the issue of like marriage equality or medical marijuana, which seems like such lost causes, a decade ago. They finally hit a tipping point, and I'm hoping that this issue, I'm not sure what it's going to take, but I'm hoping this issue will hit a tipping point. So it's important for people like you, people on this panel, just to keep plugging until we really recognize and react to this problem as the serious problem that it is. So thank you.
So thank you. I'm very happy to be here tonight. I'm going to talk about the communication perspective about global climate change. So I'm going to cover 4 basic things. First of all, what do the public believe about global climate change? What are the forces that hinder public understanding of and action on global climate change? What are some effective strategies for communicating about global climate change? And then I have a couple of resources to share with you. So I'm going to connect a little bit to what Dr. Horton and Representative Vitale mentioned. And that is, without public understanding of global climate change and without their support of climate science, you will likely see inaction from policymakers. So here's an example. In January, the Senate tried to pass an amendment saying climate change is real and human activity significantly contributes to it. We see a fairly divided vote. And what some researchers discovered is that senators were more likely to vote yes if their constituents had strong, positive, favorable ideas about climate science, and nay if they were neutral or disagreed with it. So I want to go to a okay. So here is some very current data on public opinion about climate change. And what you see, okay. So percentage of people who say climate change is not happening or it's happening by natural causes versus percentage of people who say it's human caused. On this side are Republican senators who voted nay. On this side is kind of a mixture of senators who voted yay. And you can see as we go down this chart, I guess it doesn't show you a very good. So you can see that as it shifts, it clearly affects how senators voted on this particular amendment. Pennsylvania is kind of in the middle here. We had a split vote between one senator voting yay and one senator voting nay. So if you take a closer look, if you take a closer look at some of this regional variation in public opinion about global climate change, when asked, is global warming happening? You can see that most of the country responded in the 50% to 75%, yes, it's happening. When you ask, is it caused mostly by human activity? You see a cooling, okay? Well, we're not so sure about that. But the most interesting part, and I think this really connects to what we heard earlier, is there a scientific consensus on it happening? We cool off yet. So the question is, why is this happening? What I want to spend some more time, talking about is what's happening here. So first of all, one of the big challenges to communicating clearly with the public about climate change science is that there are forces intentionally trying to confuse us. There are think tanks, front groups, dissident scientists. There's funding from fossil fuel industry to create this idea that there is doubt, that there's not a consensus. It's called Misinformation Campaigns, Efforts to Manufacture Doubt. We see the same kinds of strategies and people involved who tried to convince us that tobacco doesn't cause cancer, that acid rain isn't happening. I'm not going to spend a lot of time talking about this today because I have very little time, but for those of you who are interested in exploring more deeply some of these issues of doubt creation, Merchants of Doubt is a book and also a documentary. If you go to this website, there are a lot of resources to look at some of these different strategies, tactics. The same people who fought against tobacco legislation are fighting against global climate change. Desmog blog also tries to clear the air about the PR cloud around global climate change science. Another challenge to public understanding about global climate change is science literacy. So when I first looked at the number, 5.8 out of 9 questions, average American citizen, adult, got correct. I thought, that's not so bad. But then I actually calculated, that's a 64%. Raise your hand if you would be excited about a 64% on a test. Probably none of you, right? So that poses a lot of challenges because in order to understand the arguments, people have to be literate in the concepts about science. And one of the challenges is that the American public in general don't really understand how science works. This idea of confidence interval, we want to know, is it happening? Yes or no. But that's not the way science works, and that's not the way scientists talk. Some other challenges to the effective communication and understanding is that, in general, global climate change is pretty complicated, it's abstract, it's remote. We don't see it in our everyday lives. If you think of the images that we so often see related to global climate change, it's a polar bear sitting on a very small piece of ice. That's not in our immediate world. It's hard to relate to. It's also rather slow and incremental. So there are various psychological challenges for the public to understand. It's a challenge for journalism, okay? If you think about news values, what makes breaking news? What makes something newsworthy? Proximity, impact, timeliness, prominence, conflict, novelty. Global climate change doesn't really fit very well into those categories. And oftentimes when editors or journalists try to fit it into it, it confuses the public because it's not really about that. There's also confusion created by this idea of journalistic balance. So we want to give equal weight to both sides of the story. So if you give equal weight to the one scientist who says nay and the 99 scientists who say yay, what kind of perception does that leave the public? It's confusing about this idea of consensus. We also see across the country a loss of the science and environmental beat among news organizations, which further creates problems and challenges among public understanding. So if there's challenges to addressing this in the media, this leads to the problem of public disinterest. It's not a salient issue. There's a media effects theory called agenda settings that suggests that the media don't tell us what to think, but they tell us what to think about. And so if the media isn't doing an adequate job of covering the issue, it's not on our minds. And in fact, a recent study asked respondents about how often do you hear about global warming in the media, about how often do you hear other people you know talk about global warming. And you can see that less than 50% of people see it in the media on a regular basis or even have a conversation. So it's not a salient issue. We're not talking about it. We don't have this sense of importance. So how do we communicate clearly about global climate change? First of all, we want to have credible messengers. Again, this is very recent data. Respondents were asked, how much do you trust or distrust the following as a source of information? And again, the blue is trust, and these here are distrust. Climate scientists, there you go. You are highly credible. Family and friends, other kinds of scientists, television weather reporters, my primary care doctor, Pope Francis. And then when you get to Barack Obama, we kind of we fall below 50%. Mainstream news media is even lower than that. So that in itself is really interesting when we think about, well, who do we believe? Who do we trust? There are a lot of communication scholars looking at how do we communicate with the public about global climate change, and I just wanted to pull one example from the recent literature. So what we find is that people need precise numeric messages about scientific consensus. Don't say most or almost all. Say 99%, give a number, that's more effective. Also, simple, clear messages repeated often by credible sources is an effective strategy. Another aspect of communicating about global climate change is this idea of message framing. So one important way to relate to the audience is not tell them what you want to tell them, but think about what do they want to hear, what resonates with them, connect to their values. So since we're here at Villanova, majorities of American Catholics do think global climate change is happening. And among Christians, evangelicals, Catholics, people resonate with this idea God expects people to be good stewards of nature, which is not only here for human use. So framing messages in terms of people's value system and targeting messages that way can be effective. There's also another way to look at public opinion about global climate change. There's a group that segmented audience into what they call the 6 Americas, based on a variety of factors, specifically 2 dimensions: attitudinal valence. Do they accept or reject climate science, and how involved are they in this issue? Do they talk about it? Do they think about it? How certain are they about their attitude? So what we see is 6 different segments of the population. The alarmed segment, the highest belief in global warming, most concerned, most motivated, 13%, fairly well balanced out by the dismissives, the lowest belief in global warming. We have the doubtful, the disengaged. This is an interesting category, cautious, concerned. 44% are concerned or alarmed. So one suggestion about message framing or specifically targeting messages, those segments of the population that have low involvement, so they don't really think about it very often, they're not engaged in the issue, you give them different kinds of messages. They need visual imagery, humor, attractive sources. They need to see that there's a social norm associated with how you behave. Show them rather than tell them what's happening. Make it personal. They have to be able to identify. And then finally, the last piece that I want to talk about is this idea of fear appeals. Okay, people love to scare you. They give you threat messages. But in order to have an effective fear appeal, you need to have an effective message. Otherwise, it'll backfire. Studies have shown that using bad messages can actually cause people to desire to go out and buy an SUV, which is exact opposite of what you're trying to do. So fear, as a result of a threat message, you either have a fight or a flight reaction. That's what we do with fear. It's uncomfortable. We don't like it. So you can fight, you can reduce the external danger, which is what we want them to do, take positive action, or they can run away, reduce their internal experience. And what that means in terms of messaging is defense mechanisms click in. So maybe people deny that it's happening. They come up with these exceptionalism arguments, wishful thinking. We've always done it this way. We refuse to do anything different. We're uncertain. There's doubt. So that's the flight. We don't want flight. What we want is fight. And in order to engage the public in an effective response, there are certain criteria that you need to meet. They need to feel personally vulnerable. They need to know what specifically you want them to do. They need to have this sense of self-efficacy, which means I can do this thing that you want me to do. And there also has to be response efficacy. If I do this thing, this bad, scary thing is going to go away. They need to know that the costs are relatively low and that bad things will happen if they don't act. So there's a lot more to say about communication and climate change, but that's all I'm going to talk about today. There's 2 really useful resources if any of you want more information. The Yale Project on Climate Change Communication and the George Mason University Center for Climate Change Communication. Both of those have a lot of good resources and reports and blogs, and thank you very much.
Want to try this one?
Is there a way to turn this on?
It's on now? Okay, thank you. Okay, my job is to wrap it up by telling you by putting politicization of science, that hard to pronounce word.
Just say politicalization. I think that really works for me, even though it's wrong.
I'm somehow better at politicization. But to put it in historical and international context in 10 minutes. I'll try. The politicization of science is nothing new, but in thinking about how to talk about it in 10 minutes, I thought there are some moments of intersection of science and politics that have been really important for the trajectory of the United States and have made it divergent from the trajectory of other countries with regard to the attitudes toward climate change and ability to make policy about climate change. So let's talk about some of those moments in the United States, and then I'll compare those to another country that's been a leader in climate change policy making, and see what we can come up with. The first moment that I think is important to talk about is Rachel Carson's Silent Spring in the 1960s. This was made into a documentary TV show, and so it got a big audience, and it evoked a huge response. And it called into question, for many people, for the first time, our faith in the neutrality of science. Carson pointed out that this was about pesticides and damage to birds. And she pointed out that some of the science that had claimed that pesticides were harmless was actually funded by the industry that was producing them. And for many people, this was a revelation, that the close relationship between research labs and industry, many scientists, as the quote amply illustrated, owe their jobs to saying there was nothing wrong with the chemicals they were testing. So this helped create a policy discussion in the United States about science, which was quite useful in the 60s. The next moment, and was followed by the environmental decade, right, the 70s, with lots of environmental legislation. The next moment that seems really important, the next juncture, was the so-called Reagan Revolution of the 1980s. And Reagan just didn't think science was important, and he was often quoted saying things like trees are the biggest source of CO2 emissions and things like that. But what he did that was important, I think, was put out there a new measure of societal good, economic benefit. Reagan was the first, and this is commonplace now, but he was the first president to really propose this. The economic cost-benefit analysis ought to be the basis of policymaking, ought to be the basis on which we decide what is a good policy. So this makes basically money the measure of what is a good policy. And that doesn't sound radical to us at all now, but in 1980 it sounded more radical. There was a huge popular backlash against Reagan's assault on environmental policies, but the idea of cost-benefit took hold. The next important juncture, I would say, was George W. Bush, in which politicians took a different tack. As climate science is becoming ever more convincing as time goes on, and scientific arguments were winning in court, the tactic became twofold, really, under George W. Bush. One, redacting content about things like climate change from the administration's own agency reports. Probably the best example of that you've no doubt heard about was that the whole global warming section was taken out of an EPA report on the state of the environment. And this became known to the public only when an angry person within the EPA leaked the draft report to the press, and the two reports were put up together. So that the entire global warming section was redacted from that report. This was an effective tactic to change the meaning of many scientific reports that were produced by agencies during this administration, all the while agreeing with the principle of deciding policy on the basis of science. The other thing was what you were talking about, the false equivalency. The Bush administration was really the age of false equivalency. There are 5,000 climate scientists on this side. There are 2 on this side. And you say that this is a very polarized topic. This is a topic that's very controversial. The upshot being that it needs more study. We can't make policy so long as there's such disagreement on this topic. The Bush administration was really the master at the false equivalency and the death by study. So then we come to the current period, and probably the best 2 examples I have of what's going on now, which I guess I would call the science is wrong, and I'm brave for pointing that out, are Ted Cruz, who last week likened himself to Galileo. The things wrong with that comparison are too numerous to talk about. But the idea was sort of, I'm bucking the conventional knowledge. Climate science is now so one-sidedly agreed on the reality of climate change and the fact that it's caused by human activity in large part, that the heretic position is the sort of brave one, according to these people. A version of that was, I suppose, Jim Inhofe going to the Senate floor with his snowball and saying, I just made this snowball outside the Capitol, and here it is, March, and there's snow on the ground in Washington. You can't tell me that the climate is warming. And there's a lot wrong with that too, but the point is the science is wrong, and I am the sort of lone dissenter that's going to point out how it's wrong, and I'll be proved right again in the future. So these are kind of junctures at which science and politics intersect, maybe to the detriment of both. Well, how is it different in other places? It's useful to put the U.S. in context. The relationship of science and politics has evolved much differently in other places, and my specialty is really Germany and German energy policy. And Germany is an acknowledged world leader in energy transition. It's the 4th largest economy in the world, and it's the largest economy to commit to a medium-term wholesale switch to renewable energies. So how did it happen there? The easy answer is that the German political culture is deferential toward expertise. And so you think, well, the answer is they believed the science. But that's not what happened at all. In fact, something very different from that happened. And here's what happened. In the 1970s, they had a Rachel Carson moment. A huge energy expansion was planned by the German government in cooperation with the big utilities in Germany. Just to give you an idea of the scale, in a 90-mile stretch of the Rhine, which forms the border between Switzerland, Germany, and France, there were no fewer than 17 nuclear reactors planned, 17 reactors in 90 miles. This was just the tip of the iceberg. This met with, as you can imagine, a lot of public objection. And people were basically told they were not qualified to take part in the discussion about energy policy. A huge militant anti-nuclear movement was the result. And people reacted in 2 ways, both of which were very consequential for Germany's path going forward from the 1970s. One was the development of what they called counter expertise. That is, if lay people were not qualified to participate, then lay people would develop their own expertise. If, as was the case, it was difficult to be a dissenter on nuclear energy and be employed in one of the big think tanks or universities in Germany, because that was sort of the prevailing opinion, then people would form their own think tanks and question the assumptions on which the policies and the science were based. That is, the assumption was always we'll have linear economic growth, and that requires energy use and energy production to go up like this too. What if we proposed flat energy use? Would that destroy the economy? What if we proposed distributed energy production from small producers using renewables? Would that destroy the economy? Would that leave us without power? This was the kind of thing that the counter expertise was devoted to exploring, when the government-supported community was not willing to do that kind of research. The other, and maybe more important thing that they did, was assert that the science doesn't tell us what to do. The science will tell you what the likely results of different paths would be, but it does not tell you what to do. Environment and energy policy involves moral choices. It involves examining our values and deciding what kind of world we want to leave to future generations. It's a choice for the political system, and it's a choice to be made democratically. And it's a choice to continue over time. That is, we're not making it for once and for all. We're going to be talking about it a lot. This was what the large environment and anti-nuclear movement in Germany achieved, to keep the moral discussion front and center. It is not about the science. The science is not going to tell us what to do. It's a decision about what kind of world we want to leave to our children. And every time the discussion has veered off of that, the public has brought it back on to that sort of guiding discussion. And I would say to the benefit of, and to the eventual result of a very fast, comparatively speaking, transition to renewable energy. So it's kind of an intersection of science and politics, but in a very different way than it happened here. And this happened 40 years ago in Germany, and has recast the discussion ever since. So you find, and when climate science started saying we have a problem with climate change in the 80s, this didn't really change the discussion in Germany. It just gave added information on which people used in the debates. So now, if you approach a German, you get the Geico commercial reaction when you say, hey, did you know that a greater than 2 degrees Celsius mean global temperature rise will produce X, Y, and Z feedback effects? They'll just look at you and say, everybody knows that. That's not going to tell us what to do. It's information that we use, but we aren't getting mired in arguments about the science because we agree that the science is not going to tell us what to do. So if there's a lesson for us in the German experience, I think it's that we have to get to the moral discussion. We have to get back to the moral discussion. It was part of the Rachel Carson moment, and it was part of what guided the environmental policymaking burst of the late 60s and early 70s. And we have to get back to it. And I guess the other lesson of Germany is that if we want to get back to it, it's you that's going to get us there. The German government, progressive as it is, opposed many of the measures that led Germany on its very progressive path to renewable energy. It was the public that insisted on coming back to the arguments about what kind of world do we want to lead. So I would leave you with that. It's on you, the public, to make sure that the political system gets the argument right.
Okay, so we have some time for some questions, if anybody would like to, and there's 2 microphones up here, if you'd please use them so we can hear you. Some questions? Or comment? Go ahead.
Sue, this is a question, sort of a reaction to when you're
Not
talking.
using the microphone.
Sorry. It's a question in sort of reaction to your talking about the idea of what works in trying to communicate with the public and how climate change science seems to not necessarily fit the bill when what people need is to be able to believe that their actions are going to make a difference and that they're going to make a difference quickly. It is sort of two of the sounds like prerequisites that make an effective message and effective action. I don't know, does that
Well,
sound right?
it's not that it needs to be effective quickly. So self-efficacy and response efficacy. Self-efficacy is I can do this action. Response efficacy is that this, if I do this, it will make a difference. So it's not so much being able to show on a short term that there is a reaction, but one component of a successful campaign is feedback. So feedback can be in the form of, look at all of these people who have made this change. You are one of these people. And then over time showing them, and we have thus reduced our contribution to the problem by X amount. So people do need to know that what they're doing makes a difference. And so it doesn't necessarily have to be a big difference in the short term, but even showing that they're contributing to this collective action and being part of the solution can be helpful.
Let me just add to that. When we try to move renewable energy legislation, for example, I mean, there's a concept that different people are moved by different things. For example, you don't really talk to a lot of people about the climate change benefits of renewable energy. You might talk about good green jobs, that people are concerned about the economy. You may talk about energy independence. You may even, there's a lot of studies out there by the defense people about national security interests and how climate change can destabilize countries. Religious people, the stewardship of the earth issue. I mean, I think what you do, you have in moving an issue, you have different message. Different people are receptive to different issues.
Can I just add to this? Last week I was in Vienna listening to a climate scientist about the grave state of our planet, and I gave a talk as well. And yesterday I was down on Capitol Hill trying to talk to a variety of senators and aides about this problem, and I believe we should talk about climate change as a crisis. Because when we had an economic crisis, we printed money and we got the banks and the car firms out of trouble. And climate change is a crisis. We have 17 years to mitigate against climate change. That's the latest information coming out of the climate model. 17 years. Ask yourself how old you are and where you will be in 17 years. Because if we do nothing to go against climate change, and so I was thinking about that, how old am I? So I will just be before I'm 60 years old. My daughter will be, how old will you be? 30? I should know this. You will be 31. You will be just starting your life. And the environment can be ruined. Our society will be decimated. And my daughter will not have the future I have. And that is how serious it is. We have to act. It's not about, when I started doing climate change, when I did my PhD about 1998, climate change we thought of, well, it's going to be about 2100. We had all this thing about grandfathering. You've got to leave your planet for the future generations. It's not, it's your generation, it's your lives. So you right now want to go and get a degree, you want to go and get a job, you want to go and get a mortgage, you want to own a car. If we do nothing against mitigating climate change, you won't be doing any of that. Only the very privileged few will be able to. You have to understand how serious this is. You know, I dedicate my life to this science, and if we talk about the politicization of it, whenever I talk, the Republican groups call me a liar. When I wrote this paper that President Obama did, that there was a big website funded by the Koch brothers that had a front page saying Horton is a liar, because they wanted to discredit me. I don't do lying. I spend my whole time trying to do science and trying to improve our projections. I can't get over to you about how serious this is. You have to act. You have to get your politicians to think about this election, that they must make a stance on climate change. I feel quite passionate about it. Yeah, just a little bit.
Who would know?
What are some of the organizations out there that are getting the message out right or trying to reframe the argument to the moral, conversation? I mean, from a communications perspective, is it 350.org? What are some of the bright spots out there that are communicating well?
That's really hard to say. I think that there are efforts, again, Yale climate change, let's see, I have to look at my notes here. So the Yale Project on Climate Change has a lot of really good information out there. George Mason University has good information out there. I see more things on blogs and websites than I see out as far as messages. I see Climate Central is a website that does a really good job of putting information out there. I honestly don't see any organizations that I think are doing a very good job of communicating about climate change. So I don't have a very good answer for you.
Well, there's kind of a debate within the environmental community that's been going on for a while about we need a guiding vision, sort of scaring people is, we're kind of coming down to that because it's, as Dr. Horton says, time's a-wasting. But there has to be this sort of connection of grassroots with guiding vision. And big organizations like Sierra are recognizing that they've been failing at that. The grassroots and the Washington sort of lobby end of the big environmental organizations have been disconnected. And that the grassroots has to be reconnected with a vision, with the center. So I don't know that they've succeeded in making that change, the large environmental NGOs like Sierra, but they're at least recognizing that that's got to be done.
So there's another, divestment.org is something that you should be looking into. I don't know whether Villanova are diversifying its portfolio away from carbon fuels. Are they doing that? So I don't know whether it's an organization that is trying to get big. Well, let's say Rutgers are doing this right now. They're trying to remove the Rutgers endowment from investing in our fossil fuel industry. And there are moral grounds regarding this. I mean, how can I work at a university where the endowment is being used to increase the share prices of a variety of petroleum industry? So as a group of scientists, we're trying to put pressure on the president. It's driven by the students. It's a student organization, and we help back them up to try and remove the endowment from that. But then there's a huge economic ground. So as I said, we have 17 years until we'll get above 450 parts per million by volume, which is this politically agreed target for a 2°C world, which therefore you have irreversible changes in our ecosystem. So if that happens, so a petroleum industry's assets are locked underground, and by 2040 or something, or 2030, depending on what our emission scenario is, we're not going to enable any of that petroleum to be released from our ground. There'll be such a groundswell, a panic within society. So it doesn't make political sense or financial sense, for example, for my 401k to be invested in fossil fuels, because those assets that are locked under the ground will be worthless. So that's a very good website to look at. And it's something that a student body can really energize and get Villanova to stop investing in fossil fuels. And if we can get a grant, so the state of California don't invest in fossil fuels. There are a variety of universities, Berkeley being one of them. Harvard are now doing, they have a massive endowment. Penn State, even though it's in Pennsylvania with its huge coal, are again trying to diversify itself away from fossil fuels. So that's it's a very new sort of action to try and reduce our entitlement on fossil fuels.
I wanted to add one more thing about your question. About 10 years ago, there was this discussion about death of environmentalism. And it was the difference between doom and gloom messages and positive, visions of a uplifting positive future. And I think there is still this debate going on about what kind of messages will get positive action. And there's a large segment of the scholarly community that says we can't give doom and gloom messages. That paralyzes people, that causes people to, stop paying attention. We need to show them that there is hope, that you can do something, you can make a change. And I guess that's part of the reason why I can't point to any organization that I see doing a really good job of that right now.
I just want to point out, Bryn Mawr students just were successfully able to get the Board of Trustees to look at divestment. Right?
Yes, and it's
Swarthmore did as well.
yeah, and it seems to me there's power in numbers. I mean, there are a lot of educational institutions around here, so
Yeah.
we could certainly
And it's
make a big
the whole
splash
thing-
if we collaborated.
And the divestment process was the strategy used against apartheid, which brought American students brought tremendous pressure on South Africa, right? So those are strategies. I guess I have an observation that I'd like you to comment on. I'm a philosopher, so I'm thinking about, I love the idea that the German people realize that science can't tell you what to do. Science isn't in the business of defining value and determining value. It's about determining what in fact is going on at any given time and maybe predicting what could happen given various variables, right? So the people have to, and I find, I'm wondering if there's a connection between the move to cost-benefit analysis as a way of thinking about how to organize society, which is so endemic in our culture. That, and then the strategy, of course, is not long-term gain. The strategy is always short-term. So you think about the guys on Wall Street that came up with the swap default, the mortgage swap default thing in 2007, 2008. They weren't concerned about anybody's long-term gain but their own. And that is kind of a cultural kind of noose around our neck, insofar as we are taught to think short-term. So it's very, now what's great, not great not great from a real sense, but from a rhetorical sense, is that we have to, it's becoming short-term.
Yeah.
Do you know what I mean? But I wonder if there's a cultural, you were alluding to that, the difference between Germany and the United States, that there's we really have a hard time thinking past our own nose.
Well, there are a lot of things in our political system that lead to that. You were
Right.
alluding to some of that. The whole the length of terms, campaign finance. These all go
It's like a
towards
perfect storm.
politicians favoring policies with short-term benefits and long-term costs, rather than the other way around,
Right.
which many environmental things are.
But it's
But-
thinking about yourself as a member of a whole as opposed to thinking about yourself as yourself.
Right.
Do you know what I mean? We're not good at the first. We're pretty good at the second.
Well, what if you just insist that politicians, your own representative, cut the crap and talk about what's important? You know, all this attempt to obfuscate the science is not really about the science. It's an
Right.
attempt not to have to say what your values are.
Right,
'Cause
exactly.
it's hard to make the case in economic terms. It would be hard for the coal industry to make its case against policy that would mitigate climate change if they had to make the case honestly.
Exactly.
So force them to talk about what's really at stake. And the only people who can do that are you, the constituents. The weapon you have is to throw the bums out.
Yeah, go ahead.
Sort of following on that, it makes it sound almost like if we just make the politicians all understand and listen and respond, that this could be solved. And I guess
Not
right. So question for Dr. Horton and then Representative Vitale, if maybe you could respond to that just briefly. What, in your view, is this simply, can we maintain our current lifestyle and just have this maybe relatively rapid switch to renewables? I mean, is it possible for us to do this as a society and not hit some dangerous level of warming without having sort of major changes to our lifestyles? And then sort of following on that, Representative Vitale's, then what's the sort of political feasibility of asking anybody to do that?
Well, regarding climate change, we have, when all the models that project the future are driven on emission scenarios. And so you have fast emissions, medium emissions, low emissions. And what are they driven by? Well, for a fast emission scenario, they're called representative concentration pathways, RCPs if you read the literature. So for a fast RCP, it's looking at future population growth expanding. It's looking at the amount of energy that we require, therefore expanding, and there being no transfer of technology from the developed to the developing world. So that's the worst case scenario, that we will keep on reproducing and our population will expand beyond 7 billion to 8 billion to 9 billion. Therefore, we'll have an increased energy demand, particularly from the developing countries, and we won't have the transfer of technology, particularly in the form of renewables, to those developing countries. On the other sort of utopian pathway, it's called RCP 2.6, we peak population by 2050 and it slowly declines. Therefore, our energy resources also decline, and we freely allow there to be a transfer of technology between the developed nations and the developing nations. And so that's the sort of choices that we have on a grandiose global scale. There are individual choices as well. But, it talks about, the renewable energy, let's say solar panels, and those being used far more frequently. And there are, I'm very passionate about climate change, but we do have a lot of hope regarding this. For example, the young generation do know about climate change rather than the old generation. There are more scientists on the planet today than there ever were. There are more scientists working on the problem of climate change. China, so now the biggest polluter on fossil fuels, is aware of this. This year in 2015, they are producing more energy for their increasing population by solar than they are of coal-fired. We have a president currently in office. Unfortunately, he won't be in office much longer, but he is talking today about climate change. He is aware of the problem that we face. Will it affect our standard of living? Perhaps. I don't really know that. But if we don't do anything about it, let's just think about hurricanes. If we don't do anything about it, let's think about Hurricane Sandy. I mean, as I said, billions of dollars of damage, but we think of it as a 1-in-100-year event. Once in a decade by 2050, the US economy cannot withstand that. So no action will seriously affect our standard of living. But the longer we leave it, the more expensive it will be. Princeton had a story, wrote a paper about how we can actually with current technologies, how we can actually reduce our emissions. It doesn't involve geoengineering. We do not want to be thinking about that as a solution. It's a very, very dangerous solution with unknown feedbacks. We have the current technology to do this. We just need the will.
Yeah, the,
So is there political will?
right now, no. I mean, it's not an issue that more than, you know, 2 or 3 elected officials in Harrisburg really actively talk about. There's no consequences politically to them. I mean, and I'm sort of thinking, the analogy I use, as I mentioned in my remarks, is, you know, gay rights, how that was when I graduated high school, but there's this, and how impossible it seemed to get to where we are today. And I just, there was that tipping point. I kind of, in my own mind, it was when Joe Biden publicly said, you know, sure, why not marriage equality? And then Obama got on, and then all of a sudden, the issue became one from a political perspective where you were at more political risk denying gay people their rights than you were opposing them. I mean, it was that moment. And I think that political shift has to happen. I think what the professor said about maybe what's going to cause it in this issue is just young people getting older. Maybe, maybe just sea level rise will just cause, just something dramatic. I mean, it's going to be a combination of things that's going to cause that political tipping point. I don't know what it is right now. You couldn't see it, in the marijuana issue, again, the same issue. At some point, it's like, it just shifts. It's young people getting older, becoming aware. I mean, the science is clear, but just catastrophic events like Sandy, it has to, it will happen. I mean, the question is how much in the hole will we be, when it does. I mean, how much in the hole will be when it does. But it's eventually going to be painfully obvious to everybody at some point.
And there's an economic argument to do it. Those who are out in front on this are going to be in really good shape. Everybody's going to have to make the energy transition. And it's happening here. There was a nice series that's being published in Talking Points memo. If you have Prime, which is their paid service, it's on how solar is taking over the U.S. And in the absence of a lot of action at the national level, states and municipalities are doing it themselves. This is how it started in Germany too. Those anti-nuclear activists innovated in particularly solar, but also wind technologies. Those started small. And we don't, again, time's of the essence, but people are acting at the grassroots level. They're doing it here. They're doing it all over the place. So there's, those of us who study these things from the grassroots have a lot of hope. Because the lack of national level action doesn't have to stop us. It doesn't have to stop us. And solar is getting so cheap that there's really no economic argument against it, even in the medium term. Even if what you care about is economic benefit, right, you are going to be in favor of the transition to renewables.
Okay, on that hopeful note, I think we should thank our panelists and thank you all.